The results of our spectral analysis suggest that three rhythms appear in the EEG signal: 60 Hz, approximately 11 Hz, and approximately 6 Hz. Given only these results, we may reasonably conclude that these three rhythms appear simultaneously throughout the entire 2 seconds of the EEG recording. That is an assumption we make in computing the spectrum of the entire 2-second interval. To further test this assumption in the EEG data, let's compute a final quantity, the spectrogram. The idea of the spectrogram is to break up the time series into smaller intervals of data and then compute the spectrum in each interval. These intervals can be quite small and can even overlap. The result is the spectrum as a function of frequency and time. Here's a plot of the resulting spectrogram. The spectrogram displays the spectrum in decibels as a function of frequency on the vertical axis and time on the horizontal axis. Note that the values on the time axis indicate the center times of each 1-second window. Intervals of high values correspond to warm colors, while intervals of low values correspond to cool colors. Visual inspection of the spectrogram immediately provides some new insights into the observed EEG rhythms. First, we observe a band of high power at 60 Hz that persists for all time. This corresponds to the 60 Hz line noise present for the entire duration of the recording. Second, we observe intervals of increased power near 11 Hz and 6 Hz. Unlike the 60 Hz signal, we here observe that the two low-frequency rhythms do not persist for the entire 2-second recording. Instead, one weak rhythm near 6 Hz appears for the first half of the recording, and then another weak rhythm near 11 Hz appears for the second half of the recording. The ability to visualize how the rhythmic activity changes in time via the spectrogram allows this important conclusion.